Next up, we have Jeff Hughes, CTO and co-founder of Ignis Systems, and he's standing right here.
We actually really like it when people call it Ingenious, but it's Igneous, like the rock. So I'll tell you a little about what we're doing. So Igneous, we got to kick this off though. First off, let's have a little contest. Cool tech, we talk about tech a lot. Let's talk about three things and what they have in common. First, self-driving car, hot topic, Tesla, Audi, Ford, all these folks. So self-driving car, number one. Number two, what is this? This is a VR camera. If you haven't seen this company, they're called Lytro. They actually just released another camera the other day, but this camera right here captures 360-degree view of everything around you in what's called a light field. Really cool stuff. So number two, a camera. Now what's this? This is actually a microscope. This is what microscopes look like today. It's actually called a light sheet microscope, and it captures a whole viewpoint of what's going on live, and you can watch a movie of a small organism. In fact, here's an example of what that looks like. So you've got basically a jellyfish, but if you look at the scale, it's way down here. I don't know if you can see that. This is less than a millimeter across. So you can capture this at like 60 frames per second. Beautiful, beautiful. So we got a car, a camera, and a microscope. Well, they'll all run you about $100,000, but that's not what I want to talk about today. I want to talk about terabytes per hour, because all of those pieces of equipment produce terabytes per hour of data. So if a camera and a car, so these cars are capturing 3D views of everything that's going around you and making lots of decisions about what's going on. The camera, obviously, that's just tons of content coming out all the time. And then this microscope, same thing. And well, we don't really think about in terabytes per hour, so let's talk about what usually in computer world we think of this as a terabyte per hour is about 2.5 gigabits. And if you think about that, this laptop right here can't even handle that. You know, you can get some weird connector or something like that, but it gets really complicated. And so what do we do with data that's really complicated and hard to process? The first thing we do is we go send it to the cloud. Who uses like Amazon or something like that? I think somebody said it's a tax on the VC industry, is a great way of putting it. No, we send it to the cloud because why is that? Well, it turns out we can buy this device for about $100K, and then, well, it's pretty expensive. You got to pay like a $5 to $10K a month just to like ship the data up there. And then once you get it there, it's cheap, right? That's the whole benefit of it, is you're like, oh, it's pretty easy to process and that sort of thing. That's cool. I spend more probably on the internet than I do on the device to begin with, but the real problem that comes about is that I don't buy one of these microscopes, I buy tons of them. And I don't really have the ability to put the internet connection everywhere where I have a microscope. And so now we end up with this world where we have data that you can't or won't send to the cloud. And you're like, wait a second. The cloud is exactly where I want to send my data because somebody thought about that problem. They thought about how do I organize thousands of machines and process large amounts of content all the time. Because if I do it, it looks like that. Have you seen these sort of things before? This closet that looks kind of messy. Maybe here you see grad students set up stuff like this sometimes. But these folks went out in there and thought about how do I solve that problem as a business, mechanically out there, and just make sure that it always scales, it's always available, and we don't have to think about a whole class of problems of infrastructure. Nobody wants to think about infrastructure. It's like you want the lights on always. You don't want to think about the guy who's making sure the generator's still running in the background. But the problem is that they designed it for a whole data center. They said, look, we can give you the cloud, but it's got to fit in a data center. I can't make it any smaller. So my laboratory that I have down at the UW Medical Center, it won't fit this, right? It just won't fit. And so this is why we got started. This is what Igneous thought about, is we said, how do we bring some of those cloud services that we all know and love, and it's how we process all our content today, and how do we say, look, is it possible to do it at a smaller design point? Can we shrink that all down? And so what we went and said is, hey, let's go take back to first principles of just compute, storage, and networking and say, can we go build this at a smaller design point? And what we said is we got to get this right ratio. How do we scale this all down to the right ratio? And that's what we built, is that we built this storage, networking, compute, little CPU down there, that sort of thing, and we put a whole bunch of them in a box that you can throw in your closet. And that's what we built. Well, now you're saying like mountains equal hardware. No, actually, we're not a hardware company. That was all a year ago. We're 95% software engineers, and we want to build software for all the data, interesting applications out there that are really data heavy. So things like search and analytics and all sorts of applications on top of that. And so stay tuned. You'll hear more about it. I would say go to our website, but there's even less information than what I just told you on there. So instead, email me, jeff@igneous.io. I'm Jeff Hughes, and thank you. Questions?
Why is everyone so shy tonight? Nobody has a question?
What is it?
Great question.
Great question. So it's cloud services in your premises. So if you think of storage, compute, networking, if you think of Amazon, they sell you VMs and S3 and container services, that on your premises. The question is, will it be cheaper? Yes.
One more question?
Great, thank you.
Okay, let's hear for our speaker.